So there are like thousands of versions, as your friend said, there are thousands of thousand versions of this problem. I'm giving you a very silly one, but this silly one should be enough that we start with getting into the environment of the reinforcement learning. So say that you have developed some programming robot in your first project. For example, some of you have had it on generative AI in summer. So that robot is able to just do the coding, right? So you ask it, just do this job, write this code for me in Python or Java or whatever, and I'm gonna give you a clean code, right? Old days, it was kind of assumption. Nowadays, it's ChatGPT, right? So, say you have this robot, and then after building this, you came up with this very brilliant idea that, well, I want to just make money out of my project. So the thing that I'm going to do next is that I'm going to rent it, right? So there are a bunch of companies that are looking for a programmer, and every single day I'm going to wake up, look at one company, and I'm going to send my robot there. It's going to do the programming the whole day, going to get paid and bring me back the money, okay? That's the idea, okay? Very good. And now, due to the very bad situation of the job market, there are only two companies left. Company A and company B. One of them is working in Java, the other one is working in Python, and then you want to rent your robot to one of them, right? So you have this option every day. You just decide one of the companies and you send your robot there. Okay, cool. Now, the key point of all these companies is that none of these two companies are really having a fixed payment. It means that they are not going to tell you really at the beginning of the day how much they are going to pay you today. So it totally depends on the demand of the market. And maybe at the end of the day, they pay you something, right? Now, I am going to give you some background information, but this information is not known to the agent, the robot. What is the information here? The information is that company A, the payment of this company is looking like a Gaussian distribution. It means that it has some bell density, bell-shaped density, and then the center of the bell is somewhere at the mean value 600, and then the standard deviation of that bell is 100. Okay? So that is the way that the company is paying. So it means that if somebody else has taken a look at a very long sequence of payments by that company, and it says that in average is paying something around $600 every day, but some days is paying too much. Like say, typically you can take a kind of interval 600 plus minus 3 times the standard deviation, right? So some days it's paying actually 900, some other days it's paying 300, right? So all of them are possible, but in average, when you look at the whole payments through time, it's going to be roughly 600. Okay, that's about the company A. And then company B has a different case. The company B is again looking like a Gaussian payment, but now this one has a different mean. So the mean is 400, which is smaller than this 600, but the standard deviation is higher. So what does that mean? That means, again, if you work there, in average, you're going to get 400, but this is possible that one day you get 400 plus 3 times that standard deviation, which is 1,000, right? So on some occasions, you get 1,000 here. On some occasions, you get 300 on the other one. But in average, A is paying better than B, okay? But none of these things are known to you. So this is something that I want to build as a kind of, environment. Okay? Now, what you want to do, you want to just rent that robot, and that robot is your agent. This is going to go and work every day. At the end of every day, you're going to get a reward, which is essentially the payment. And the thing that you want to do, if you just give it for 1 month, you want to collect the most possible payment, right, within the month, right? So that is your target, and in order to do that, you are going to design a policy, right? No worries, this is not the way that I'm going to define agent environment policy, or we're going to have the concrete definition on Friday. But just to give you the example, you have the particular policy. What is your policy? This is the strategy that you are going to rent this robot out, right? So then every single day you decide whether to send it to company A or company B, and then pi of t, day t, is actually either A or B. So when you decide on day t to send it to company A, then the policy is A. When you decide to send it to company B, the policy is B. Yeah? So that is the policy here. And now the question here is that what is the optimal approach for renting out your robot? How do you define the optimal approach? I mean, obviously we want to have the maximum reward, right? The maximum money we have collected out of rent, right? But the whole issue here is that this rewarding system is random, right? So the company is waiting till the end of the day, looking at the job market, and then it's going to pay you. So before you send your robot there, you're not going to have any idea what you're going to collect at the end of the day, right? So that is some sort of challenge here to define the optimality. So the whole process is stochastic. What do we mean by optimality? And this is the classical question happening in many statistical problems. And what is the best solution to that? If you want to define the optimal approach, how do you define it?
Optimal expected return.
In expectation, right? In average. So you would say, okay, I don't care about one particular sample that is happening, right? So then just one day. I hope that this is going to work very fine when it goes over time, right? So in average, this is the way that you're not naively greedy on collecting money. So you would say, okay, maybe I lose a bit today, but it seems that tomorrow I'm going to get more, and then I'm going to compensate for that, right? So this is the way that you usually do it. So you want to have your average return. And what is the average return? I could define it mathematically as the expectation. So this is the mathematical expectation of this particular reward. So what is this RT? This RT is the payment that you have given at the end of day T, right? So it depends on your policy, obviously. It depends whether you have sent your agent to the company A or B. But depending on the company, you are going to get one reward, right? And that reward is actually ranked, right? Now, say you have done it for 2 different days. The best way to define it is that you average all of your payments over those T days, but it's still they are random, right? So you're going to take an expectation of that. If you don't take the expectation, you're dealing with a random object. You cannot optimize. Everybody's cool? Yeah? Questions? So the target is that I want to get this average return in a period of T days maximum. Yes.
This expectation taken over return policies?
Over return. No, is not only over the policy, also over the companies of their payments, because the company is also paying you random, right? So, but of course, I mean, the policy is going to impact as well, definitely. Yeah, we're gonna see. Other questions? Yes.
I was wondering why we use average return instead of the sum of the return.
The same thing. Just I wanted to keep it like
Oh, okay.
like finance. Yeah, but you're right. You can. Questions? No question? Cool. So if you got no question, now my final target is that if I'm renting it out for 2 days, then this average return is going to be maximum. So I want to get the maximum average money that I could get paid. Okay. Now, one question here: expectation, the marginal expectation, and the conditional expectation. Do you have a clear idea what they are? If you don't have, I can write it down on the board. Yeah, I write it. Okay, no worries. So, how do you say I have first? Let me just define. So first, just the expectation of one random variable. So, if I have x and say this X, this is a random variable, I show it in capital. So if it is distributed with some density Px, how do you define the expectation? So what is the expectation of X? So it's gonna be, if it's discrete, you're gonna write it as summation, but since we're working with the continuous random variables here, it's gonna be integral, right? And then anything inside the expectation is gonna be X here, P of X dx, right? So this is your expectation, right? Now, if instead of X, I replace it with anything else, so say I have F of X, what's gonna happen here? This X gonna be F of X, right? So you're gonna write it down F of X, okay? So that is a marginal expectation. The marginal on X, there is nothing else involved, right? But you can have conditional distribution as well, right? So what is the conditional distribution? So I can write it down as P of X given Y. So this P of X given Y, when Y is something fixed for you, right? So I tell you Y is that, and once you know Y, you can write down the distribution of X, right? Now, for the given Y, you have a distribution. Now, how do you define the expectation of X given that Y equals by what? How do you define this? When Y is fixed to particular value of Y, then your distribution is going to be P of X given Y, right? And then you want to just average X over that distribution. What should you do? You're gonna multiply this X here, you integrate it over X, right? Everybody's clear? Now, can I also go ahead and average it over Y? Yes? How should I do that? Okay, I want to now do another color. So if I want to do the expectation now with respect to Y, okay? Here, the expectation was with respect to X. Yeah, X was the variable. I just take I took the expectation. Now, if I want to take the expectation with respect to Y, what should I do? This guy is a function of Y, right? So multiply it with P of Y, right? And then this is the function of Y. So this Y is the guy which is the variable here. Getting it multiplied, and then you take the integral with respect to Y, right? Everybody's clear? Everybody's cool? Now, this guy here, I took first the expectation with respect to X for a particular Y, and then I averaged it over Y, right? So I could write it down as this expectation of the X itself, right? With respect to anything there, right? Everybody's cool, right? Everybody's recapping this notation, right? Cool. So if you have that one now clear, then let's go for the example. So yeah, we already looked at the board, so we don't need to look at it anymore. And first of all, if I do know the distribution of the companies, company A and B, I do know that they are paying Gaussian with those means and variance. What is the optimal strategy? Don't. You don't know it, of course, but if you know it, what is the optimal strategy? You want to maximize your, yeah, go ahead. Average, yeah, exactly. So you're going to go for that, right? All the time. If I do know that, I'm always going to send it to company A because paying more average, right? That is obvious, and you can simply see it mathematically. So I want to maximize this expectation of this average. This expectation can simply go inside the summation, right? So that's easy. I'm going to go inside this one here. Now, let's say that I don't know exactly what I should do. So I'm going to decide that I'm going to send it for TA days to company A, and TB days to company B. What's going to happen? Well, I'm going to have TA, and in all of those TA days, the expectation of this reward is the average of company A, right? So it's going to be mu A, correct? So that is going to show up here. Then company B, I'm sending TB different days. And for every single of them, I'm getting an average mu B, right? TB times mu B, right? So this is the total thing I collected within the T days. I divided by T. That is going to be the average return, correct? Everybody's cool? Now, first of all, if I add up TA to TB, what's going to happen? It's going to be T, right? If I have 100 days, maybe I send 20 days to A. The remaining 80 days, I send it to B, right? So TA plus TB is going to be T, so I can write TA to be T minus TB, right? And both TA and TB, both of them are smaller than T, right? Less number of days than the total number of days I've worked. So if I do that simple notation here, so I'm going to say that my average return is this term. Now, instead of TA, I'm going to replace it with T minus TB, okay? Right, cool? Now, the first T here, this T, divided by this T is going to be 1, right? So I'm going to keep that 1 outside. Then I have mu A times TB over T. I have mu B times TB over T, right? So I can just factor out TB over T, right? So I can write it down in this form first. So this term here is going to be 1 minus TB over T. This other thing, mu B remains here, TB over T, right? Everybody's cool? Now I can factor out TB over T, right? That fraction. And this is going to be, I'm going to remain with mu A first, and then TB over T times, someone tells me? Mu B minus mu A, right? Yeah, I wrote it minus, sorry, minus mu A minus mu. Yeah, same, right? So everybody sees that, huh? Basic calculation. Right, cool? Questions? No question. Okay, now TB over T, that guy. It can be 0 when I never send my agent to company B, right? It can be 1 when I always send it to company B, right? So that guy is always between these two values. And if I just replace those values of mu A and mu B to that, this is going to be the case, right? So the reward that I'm going to collect in average is going to be the 600. This is the higher payment. The company A, which is paying me higher in average, minus that difference between the two mu values, which is in our case 200 times TB over T. Can this guy get anything more than 600? Never, right? If you choose to do anything, this fraction is going to be some positive number between 0 and 1. And then this means that I'm going to get paid less than 600, right? So, moral of the story, TB over T, as I said, between 0 and 1. This is when you always work at A. This is when you always work at B. And the best idea is that you put this guy to be 0. Then you're going to get the best payment ever, which is average payment, which is 600. Means that even though it might be few days where at company B you get 1,000, but the right strategy, given that you don't have any idea about the exact payment every day, is that you always go with the guy which is paying you more in average, right? That makes sense, right? Everybody's cool? Okay. That's cool. So this is the best return, average return that you can imagine if you work for T days, right? You can never go above that, right? But the point here is that when I wanted to compute this, I assume that I do know the distribution. I do know how is our behavior of the payments for every single company, which is not the case in practice, right? So in realistic case, we don't have really an understanding of that distribution. If we do know that distribution, then we're always going to send our agent to company A. This means that the best policy that we can play with is that at every single day, the choice of the company is A, right? This is the best policy. But we cannot do it because we don't know the distribution, right? And this is what happens in practice. In practice, you don't know what is the distribution of the payments, right? So I gave you this as a kind of side information, which is inside the environment, but in reality, you're just going to send your agent, and that agent works, and you see some sample payments, right? Today you've got 600, tomorrow you get 300, and so on, right? So it might be that the first day you go to company A, this is one of the bad days for company A, it's gonna pay you 300, and then the day after you say, okay, damn it, I'm gonna go to company B, right? And then this is one good day for company B, and then it's gonna pay you 1,000, right? And then you keep on playing company B, right? But in average, you're getting paid less, right? It's a very obvious thing, but this could happen in practice, right? Okay, so now, in practice, what we can do, we can eventually do some observation. We can have some simple observation by going and working at those companies a bit. And all of those sample payments that we get from the companies, we start to conclude which company is the right one to go for, right? Now, this is what is going to happen in practice. So in practice, you are going to have a kind of rendering policy, and you build that rendering policy based on the observation that you have done from the environment. And you can see here that this observation is totally random, right? This is just one sample coming out of your environment. So if you keep on working forever, you're gonna get maybe conclude totally different strategy, right? So now, let's take one simple case where we are just doing one, kind of greedy approach to just design a policy. And let's see how far away we can get from this optimal policy. So the best, optimal reward. The best return that we can get is 600. This is when we do some genie told us that company A is paying better than average. We'll keep on working there. But what's going to happen if we are going to do it in practice by the greedy approach I just told? So what do I mean by that? Let's think of this dumb policy. So I'm going to flip a coin. Oh, sorry. Yeah, I didn't want to say my policy first. Sorry. This is the greedy policy of random play. So first, let's discuss this one. Then we're gonna get into my greedy. So let's first consider this dummy random policy. In this policy, I'm going to just get a coin every single day. I'm gonna flip it. If it's half, I'm gonna go to company A. If it's tail, I'm gonna go to company B. Okay. So on the coin is very fair, so it's gonna be 50% of the chance I go to A and 50% of the chance to go to B. And now I want to see out of this random policy how much I'm gonna get in average. Now, what do you think? What can it be the average payment in this case? 500, right? So 400 is company B, 600 company A. Half of the time you're here, half of the time you're there. In average, you're going to get 500, right? So you can do it simply by writing down those equations again. So if you write it down this way, then I just want to do it to give you the idea of notation, right? So I want to just take this expectation. When I want to take this expectation, my R, my reward at the particular day T, that I don't know what is that one, right? Because it depends on what the policy says. And the policy is totally random, right? I'm going to flip the coin, right? So now, let's say that I flip the coin and that coin shows me A. Then that RT is going to be R that I get from company A. If that coin tells me B, then that RT is going to be the reward I get from company B, right? Everybody's cool? So what I can do, I can fix the policy first, and then I average the reward. And once I average the reward for the policy, then I average this average reward for all the policies. Now, what would it be in our case? What are the possible outcomes for pi in our case? What could be your pi? What could be your policy on the AT? Can it be company C?
A or B.
No, it's gonna be either A or B, right? These are the only possible cases you can do, right? So what you can say, okay, let's say that pi, my policy on day T is to go to company A. So this means that now this RT is eventually the payment by company A, right? And then you're gonna take the expectation of that, correct? Again, your policy is to play B, then this means that your RT is going to be the reward that we're going to get paid from company B. So you take the average of that one, right? These are the two possible outcomes of your policy. Now each of them is happening with probability half. You multiply them with that probability, you sum them up. This is the average with respect to pi. Everybody's cool? And this is exactly the 500 that you set, right? So if I put the first term here, this first expectation is going to be 600. This is the average payment of the company A. This one is going to be 400, and then half 600, half 400 is going to add up to 500, right? What you intuitively already said, right? Just wanted to indicate, just clarify the notation for use later. Okay, so now here, if you play this random strategy, random policy, the thing that is going to happen is that you are going to get paid in average 500. And you are going to get a loss of 100. And this loss is as compared to the best you could get, right? Sometimes people call it regret. And you might say, okay, there was no way to get rid of that because eventually I have no idea about the distributions. So I randomly choose this guy or that. Huh? But actually, this is not the case. I mean, you can actually do better than that. You can play in a way that this average return that you get, it's not exactly 600, but you can make it as close as you want to 600. How you can do it? Let's start with this idea that I told you. So what you have already done here, you have done exploration, right? So you have gone in company A, you have worked there half of the time. You have gone to company B and worked there half of the time. Out of those data, you can get a bit of sense about the payment, right? So if you, as a person, want to do that, you're going to work a couple of days here and a couple of days there. And you say, okay, these guys seem to pay better in average, right? It's true that the first day they paid me less, but I worked 10 days and it seems to pay better as compared to the other one. So I'm going to stick the rest of the days there, right? So what you have done eventually is that you first done some sort of exploration, right? So you have gone to these companies, you have collected a bunch of samples. Out of those samples, somewhere in your mind, you started to plot that bell curve. And the center of that bell curve for company A is a bit better, right? And then at that point, you start to exploit what you have already concluded out of your exploration, right? So you started to conclude that it's better that you go ahead and work for company A. And this is the right way of playing this particular game. So, yeah, so let me just, yeah. So when you do that, this is eventually what we call it a learning procedure because you start to collect some data and then you start to estimate the behavior of the companies. And out of that, you try to build your own behavior, right? So this is a kind of learning process. But let's just try this particular policy and then see how this policy works. I have a few minutes. So how this policy works as compared to the other one. So what I'm going to do, I'm going to do the most greedy one. So I'm not going to work, I'm not patient, I'm not going to work for a couple of days in every company. I just work for one day, right? I'm going to work for one day at company A, one day at company B, and then after that, I'm going to compare the payments. Day one, I am at A. If A pays me more than day two, which is I am at B, then I'm going to keep working at A. If I work at, if on day two I get better payment, then I'm going to keep working at company B. Okay? This is the most greedy way of playing, but it turns out that this one is better than playing random. So. Now, let me just show the return that you get out of this policy by G1. So I write it down 1. This one is simply because I tried every company for just a single day. Okay. Now, everybody's cool about the Gaussian distribution, its Q function, and also the property of summing multiple random variables. Or you want me to explain it?